Hey guys, this is another video, and today we'll be talking about electric field. After this video, if you like what you see, please comment, share, and subscribe. So, what we'll be doing today is actually quite simple. I won't be going into much details. Maybe there will be a second video, probably. There will be a second video for this particular topic. So I'll be talking about electric field. So first and foremost, I'd like to explain what field is, because I believe if you can understand this particular concept, then you'll be able to understanding electric field will be quite easier. Um, a field, a field is more like a space or a region where a physical quantity is being experienced. For example, we have a football field. What happens on a football field? On a football field, we have players playing. Definitely, they are playing soccer. So that's what happens on a football field. Now we have basketball court or basketball field. What happens there? They play basketball. Now, in an electric field, what happens in an electric field? So we have charges, we have electricity, all working together. All these happens in an electric field. Now, an electric field, I will define an uh, electric field as a space or region where electric force is being experienced. Yeah, it's as simple as that. Now, in an electric field, we have uh, things like charges, and we have two types of charge. We have positive charge, and we also have negative charge. And we have things like potential difference. I will explain all these concepts soon. Potential difference. We have what else? We have electric current. Yeah, we have electric current. All these terms all happens in an electric field. Now, let me start with charges. Now, without charges, we can have what we call an electric field. Charges are the basic, they are the basic concept if you want to understand what goes on in an electric field, or how electricity is being generated, or how electric force is being generated. Now, without charges, this concept cannot really be understood. So we have two type of charges. We have the positive charge. We have the positive charge, which I will call Q plus, and we have a negative charge, which I will call Q negative. Now, there's a rule that governs this. We have like charges attract each other. Sorry, like charges repel. Sorry, like charges repel each other. Then unlike charges attract each other. Now, let me explain what this means. Now, for example, when you have a positive charge and another positive charge, what this means is that there's no sign of attraction. Now, a positive charge loses electron, Now, electron goes out of a positive charge. Electron goes out of a positive charge. Now, there's no sign of attraction. There's a repulsion. between these two charges. But when you bring, same thing goes for two negative charges. Now, negative charge attracts electron, it accepts electron. So electron goes into a negative charge. When you bring these two, there's a repulsion between them. But on the other hand, when you bring a positive charge and a negative charge, now this gives out electron, right? And this accepts electron. So you can see electron goes into the positive and this gives out electron. So there's an attraction between the positive and negative. So that's why I say like charges repel each other, unlike charges attract each other. Now my next concept is potential difference. But before I explain potential difference, I would like to go to explain what electric current is. Now, in an electric field, there's always a current that moves. Now, before we have an electric current, there are some things that must have gone, that must have been done, or before an electric current can actually happen. For example, if you look at your phones, your gadgets, when you charge them, you can only charge them because there's an electric current that passes through them. Now, before we can have electric current, we have what we call charges, which I just explained. We have what we call voltage, and we have what we call current. So, electric current. Let me try and explain that. Now, electric current is rate of flow of electric charges in a circuit. Now the formula for this is Q equals to IT, where Q stands for charge and I stands for current and T stands for the time it takes to flow. Now for example, if I have a question that says if a charge of 5 times 10 raised to power 9 coulombs flows through a conductor for 60 seconds, find the current. This is quite a very simple question. Find the current. So we know our formula to be Q equals to IT, and we were being given charge, which is 5 times 10 raised to power 9. So we have 5 times 10 raised to power 9 equals to I. We are looking for I, which is our current. And let me write the SI unit for this. This is in coulombs, which is Q. This is in ampere, which is A. And this is in seconds, right? Which is can be written as S or something. So IT, our time is 60. So we can have 5 times 10 raised to the power 9 divided by 60 equals to I. So if we do this, I think our answer should be okay. Our answer should be 8.33 times 10 raised to the power 10 raised to the power 7 ampere. So it's as simple as that. So this is the concept of electric current. So it's the rate of flow of electric charges in a circuit. So we have different type of circuits. You know, when you look at buildings or houses, these houses, they have their specific circuits, how electricity moves or comes in through uh, comes in through the house, and we have complex circuits, we have simple circuit, depending on whatever load or whatever function they want to use the circuit for. We have some circuits can be as complex as, for example, so now I'm discussing about circuits. For example, some circuits can be as complex as this. Uh, yeah, so we can have some circuits as complex as this, and we can have some other circuits that is as simple as, that is as simple as this. Yeah, so it depends on the workload. It depends on the workload of the sample. Depends on the workload of the sample. And so we have two major types of circuits. We have two major type of circuits, or three. Let me say three. The first one is closed circuit, and the second one is open circuit. Sorry. Second one is, and the third one is I'm trying to remember the third one. Short circuit. Yeah, third one is short circuit. Now I'll explain this briefly. So for closed circuit, let me draw a diagram, which I think it will be easier to understand with a diagram. So for example, if we have a bulb, or a lamp, let me say a lamp, that gives out light. Now there's a wire that comes through the lamp, right? There's a wire that comes through the lamp. Let's say this is our switch. Now the wire passes through here. And let's say this is our battery. Yeah. So this battery or current, then this switch. Now, if you look at this switch, it is open, right? Now, if I decide to close this switch, now what happens? Current flows through. Our current passes from here. So current flows through. Current flows through and goes up. And what happens to our bulb? It lights up. So this is closed circuit because the switch is closed. But when we come to open circuit, so let's find out what happened to our bulb. Yeah. Now we have a wire that runs through, right? So let's see when our circuit is open. Now it is opened. Now let's say there's a battery here. Okay, now our circuit is open. This is our switch, which is open. Now when this battery gives a current, it flows, and because it is open, there's no continuation. So what happens to our bulb? The light goes off. So this is what they call an open circuit. So when your circuit is open, there's no current that flows through. The current that flows through stops at this place, but immediately it's closed, just like our closed circuit. What happens? We have a current that flows through. Now the last one, which is short circuit. Now short circuit is a closed circuit without a bulb. So we have a circuit without a bulb. Now if you look at this has a bulb, this has a bulb, it has a load on it. So when we have our battery, so we have this. When we have this, so this is what they call a short circuit, a closed circuit without a load, or let's say bulb for example, without. Okay, so the last but not the least that I'm going to explain in this video is potential difference. So these are just basic concepts in electric field so that it will make you understand how what goes on in an electric field, how electricity is being generated, how they work, how your phone is being charged, how you power up your lights in your room and all. I mean, there are more to it, there are more complex things to it, but for now, I would just like to talk about this. Then probably there will be a second video for this particular topic. So potential difference. Now I would like to explain what potential difference means in a very easy way. Now if you look at this circuit, for example, let me draw a circuit. This let's say this is our battery. Now when you connect a wire to your battery, what happens? It gives out current, right? Now before current can actually come out of this battery, there's something required. There's that force required to bring out current from this battery. If we don't have that force, then there's no current coming out of this battery. For example, let me use an illustration. When you have your tap running, when you open a tap, what comes out? Water. Now there's a pressure that brings out water from wherever it was stored, from your reservoir or something, that brings out water out of the tap. Now same concept goes for your electricity. Before an electricity is being generated, there's that force, there's that pressure that brings out electric charges, from your battery, from your source. Now that force is what we call potential difference. Now potential difference is between any 2 points, is the work done in a positive moving a positive charge of 1 coulombs from one point in the electric field. It's as simple as that. Electric field. And we can denote potential difference as V, which is voltage. So more explanation and more calculation will come in the next video. That will be electric field 2, where I will talk about electric field 2, where I'm going to talk about Ohm's law. I'm going to talk about resistor or resistance. Anyone? Resistor and resistance. Resistor and resistance. I'm going to talk about conductors and conduction too. Then I will do more detailed explanation detailed detailed explanation and calculations too. So physics is not complete without doing some calculations. So this will be the end of today's video. If you like it and you enjoyed it, please subscribe and share. See